Hey guys, this is lesson 2.4. So we're still looking at systems of equations, and we're going to look at a few examples. So this is Do the Math in lesson 2.4, Solve Linear and Quadratic Systems. Alright, so the first thing it says is tell which ordered pair is the solution to the system shown. Show your work. Alright, so yesterday we looked at how we could take the ordered pairs and we could substitute them into the equations to see if they are a solution. So we're going to do that quickly, and it wants us to do another method, but we're going to look at this very quickly and see if we can determine which ordered pair is a solution. So a system means two or more equations, so if the point is a solution, that means it has to work for both equations. So the first point is 2, -7. So if we take 2 and plug it in for x, 2 minus 2 is 0. 0 squared is 0. Minus 7 equals -7 for y. So it works for the first equation. Now check it for the second equation. 1/4 of 2. 1/4 of 2 is 2/4. And if you do 2/4 x, 2/4 minus 3, that is not going to give you -7. So the first point works for the first equation, but not for the second equation. So it's not a solution to the system. It is a solution to the first equation, but not to the whole system. All right, let's check for 1. 4 minus 2 is 2. 2 squared is 4. 4 minus 7 is -3. So that one does not work. For the first one, you don't even have to check the second one. And go to the next point. 0 minus 2 is -2. -2 squared is 4. 4 minus 7 is -3. So this one works for the first one. If you plug 0 in for x, 0 minus 3 equals -3. So we can see that 0, -3 is the solution. If you want, go ahead and check the last one just to make sure. 3 minus 2 is 1. 1 squared is 1. 1 minus 7 is -6, not 0. So the third point here is the only one that makes both of those equations true, which means it's the solution to the system. All right, part A says, first use substitution to write the system in a single quadratic equation. So they're going to do it a little bit differently. So let's look and see if you remember substitution from Math 1 or Algebra 1. Substitution means you literally substitute one thing in for something else of equal value. So if we have an equation here and it says this is equal to y, we can substitute that here in the first equation. So you can see 1/4 x minus 3 equals, this right here is just them substituting the second equation into the first equation. Okay? All right, when they do that, they're going to say, what is x minus 2 quantity squared? That's a binomial squared, so remember you have to worry about the middle term. So if you've got x minus 2 squared, that's what we're expanding right here. That's the same as x minus 2, x minus 2. So that's a perfect square trinomial. So you've got x times x is x squared, minus 2x is minus 4x, and then -2 times -2 is plus 4. This is a big topic on the ACT. You know, it's always the first term squared twice AB. This is A, this is B, -2x times 2, -4x, and then the last term squared. So that's something, if you learn those formulas, that makes it easier on the ACT. All right, so that means there is a plus 4 that goes here. You can see all we did was take this number here. And then they're going to do plus 4 minus 7 is -3. And then they're going to set it equal to 0. Okay, so in order to solve, they got to set it equal to 0. So they're moving everything to one side of the equation. So because x squared minus 4x minus 3 is all the same signs, that means they basically moved all of this over and then just flipped the equation around. I don't know why they did it that way, but it's fine. So that means we have to subtract 1/4 x to the other side. And that means we had to add 3 to the other side. And then here we're just combining. So x squared comes down. We've got negative 4x and minus 1/4 x. So that's negative 17/4. The negative's already there, so I'm just going to put 17/4. And then you can see the negative 3 and the positive 3 cancel. So remember, this is the same as 16 over 4. 16 over 4 gives it a common denominator. And then the 16 plus 1 is where I got the 17/4 there. All right, so how does that help us? That sets us up into a quadratic equation. And then they want you to plug it into the quadratic formula. All right, so if you want to do that, you can plug it into the quadratic formula, and you can see the x's here that are supposed to be solutions. All right, let's see if we can do this quickly. This is not the easiest method, so I'm not sure why they're doing this, but we'll look at it here. So b is 17/4 plus or minus b squared minus 4ac. If we look up here, there was no c value. There's no number left, so c would be 0. And 2 times a is just 1, because it was 1x squared. They've simplified this down to here. We've got 17/8 plus 17/8. So that's 34 over 8, and 34 over 8 reduces to 17/4. Whoops. Wrong box. All right, 17/4. And if I do 17/8 minus 17/8, that gives me 0. So that should be correct. Let's see, I plugged in something wrong here. Negative 17/4 minus 4 times a times c, 2 times a, negative b would be a positive 17/4. Well, I don't see what the mistake is here. Anyways, this is the formula. You're going to plug in A, B, and C. We got the correct x's at the bottom, so maybe there's a typo in the system. All right, let's go ahead and look at part C. Substitute each x value found in part B in the equation to find the corresponding y value. All right, let's substitute 0 in first, because that makes it very easy. If you plug in 0, 0 times anything is 0 minus 3 is negative 3. So that gives us our 0, negative 3 that we said right off the bat is a solution. All right, so we can go right here and plug in 0. Oh, they must have plugged in the other number first. Let's plug in 0 here. Equals negative 3. All right, and in the first equation, it looks like they plugged in the 17/4. So all they're doing is taking the equation right here, and they're substituting the x we found, 17/4, in for x. So let's plug in 17/4. That's going to be 17/16. Remember, when you multiply across the top and you multiply across the bottom. 17/16. Now we have to get a common denominator. So if we get 16 on the bottom, 16 times 3 would be 48 on top. And 17 minus 48 is negative 31/16. Let's see how that works out. All right, so that is correct. So there must be something wrong with the one up above it. All right, and we found from the very beginning that 0, -3 is our solution. All right. So when it said which ordered pair is a solution to the system, even though there were two solutions, we found both of those solutions using this long process. But from the very beginning where it said which ordered pair is a solution, we could plug those in quickly and easily and find that. All right. The solutions to the system can be determined by graphing the line and finding the intersection points. Use the line tool to graph y equals -2x minus 2. So if I'm on the line tool, I can click a point at -2, and I can go up to back 1, that's a slope of -2, and I can see that it has a point here and here that are intersection points. So let's see, find the intersection, or find the solution would be 0, -2, 0, -2. That came from when the line hit the parabola right here. That's 0, -2. And the other intersection point is -4, 6. All right, there's another one here where it says find the ordered pair that works. Let's plug these in like we did the first time. 0 squared is 0, 5 squared is 25, so the first point works for the first equation. Let's check it for the second one. 0 times anything is 0, plus 2 is 2. 2 does not equal 5, so this one does not work in the first one. 0 squared is 0, -5 squared is 25. Plug it in for the second one. That becomes -5 times negative becomes positive 10/5, which is 2. 2 plus 2 equals 4, not 0. Let's check 5. 5 squared is 25. 25 plus 0 is 25. That one works for the first one. Plug it in for the second one. That becomes -10/5. So that becomes -2 plus 2 is 0. So that one works. Let's check the last one just to make sure. That one's 25 equals 25. It works for the first one. For the second one, it does not work because that becomes positive again. So the answer is 5, 0. We're going to skip through plugging it in all this equation stuff and go down here and see if, I think that's the one. 5, 0 is the one we said worked for both. And we can see that that is a solution. So that's just an easier, quicker way to do it. If you want to work through the other, feel free to do so. All right, again, the solution can be determined by graphing the line and finding the points of intersection. Okay, again, if you graph the line, x plus 3, 3 has a point here, has a slope of 1. So up 1 over 1 or down 1. So you're going to see two intersection points here. The video is going to stop here in just a second, but you can see that the solutions are 0, 3 and -3, 0.